Okay, this video is also chapter 14. It's going to describe atomic size in detail. So we're going to start by just looking that atomic size increases going to the left and it increases going down. The more important trend, if you have to pick, is the group or up-down trend. So looking at that, what you're going to see is we need to explain it a little bit. For the A, you'll be able to explain. So here's Columbic Attraction, a bit of a summary. And it just says as the magnitude of the charge increases, the attraction increases. More protons, more attraction. As the distance between the charged particles increases, the attraction decreases. More energy levels, less attraction. You can pause and copy this if you need. Now, as you go to the left on the periodic table, these elements on the left, like beryllium, has less protons than fluorine. Since beryllium has less protons, those positive protons have a weaker pull on the electrons because there's less of them. When you have a weaker pull, the electrons are able to spread out. Versus fluorine pulls his electrons close and he shrinks in size. The other trend, this arrow, pretty much says as you move down the periodic table, there's more energy levels, so you're larger. So those are the Y's for the A. But let's just kind of get through how to do a couple. So the first one is I'm going to have you compare beryllium, carbon, and fluorine. Okay? And since beryllium's at the left, he should be larger than fluorine. So I could say fluorine is smaller than carbon, which is smaller than beryllium. And I could just do that. Now, I could also do a group comparison. I could do bromine and iodine, and I'll do fluorine since he's already highlighted. So looking at those three, the largest one should be at the bottom because there's more energy levels. So iodine is going to be larger than bromine, who will be larger than fluorine. And that's how you do those. What would happen if I mixed them? What if I had a calcium and a barium and a bromine and an astatine? There's a mixture. Well, I'd have to stop and think just a little bit. So let me put some thinking paper in here. So this is what I would do. I would say, well, the most important arrow is the up-down arrow. So barium and astatine tie for largeness according to this arrow. So I know that barium and astatine are currently in a tie. And their calcium and bromine are also in the same row, so they are also tied. So this is my thinking. Then what I'm going to do is I'm going to look at the second arrow to break the tie. Between barium and astatine, barium is further left, so he would actually be larger than astatine. And between calcium and bromine, calcium is further to the left, so he would be larger than bromine. So pulling that answer together, that would be your final answer when you have a mixture.